Check, check, check 1, 2, 3, check, check Niasi, check. All right, Algebra 3, this is what, test 3? Test 3. All right, starting with the most missed questions. All right, most missed is, let's see, let's go ahead and put a date on this so that we know. This is the 2020-2021 group, okay, that missed these questions in this order. Question number 5. Question number 5. All right, let me get over here in the book. The book. All right. 3B, listen, this is number 5. Now, you guys have the answer key in front of you. I don't have it in front of me. So if I make a mistake, we'll go back through. All right, so we get something like this, which is a beautiful circle. I'm really impressed with that. Okay, we get something that looks like this. Let's see, we've got 80 degrees here. All right, make sure that this is the correct test. Does this look like what you guys have? All right, we've got X here, Z here, and Y because it says so. All right, so we should know a couple of things, even just looking at this. How many degrees are in a triangle? 180 degrees, right? How many degrees are in a circle? 360 degrees. The other thing that we should know is that an intercepted arc is half of the inscribed angle. An intercepted arc is half of the inscribed angle. Is this something we learned if we watched our notes, right? Okay, so you didn't know that. All right, so let's look at this 70-degree angle. Okay, it is an inscribed angle. It intercepts what arc? Z. So Z equals twice as much as 70 degrees, right? So I find Z by taking 70 times 2. What is 70 times 2? So Z is 140 degrees. Okay, does that make sense? Yes. Okay. Now we have this 80-degree angle, all right, which we can use to solve for Y. Y equals what? 80 times 2, right? So Y equals 160 degrees. Now, there's two ways to find X. Okay, either you can solve for the missing angle of the triangle, right? 80 and 70 is 150, which means there's 30 degrees remaining, and that 30-degree angle is going to intercept X, correct? Or I could say that 140 plus 160 is 300, right? And how many degrees are remaining? 60 degrees are remaining. Do I get 60 either way? All right, but you need to show your work for how you got that remaining, okay? Whether or not you're showing, 30 degrees, 30 times 2, or you're taking 360 minus 300, right? Either way, I get 60 degrees. I don't care, so long as we know that X equals 60 degrees. Do we understand this? Which, what makes me feel good about this is that it's not that, well, it's the most missed question, but what's nice about the most missed question in this case is that it's really easy, right? Which means it can go from being the most missed question on the test to the question that everybody gets right really quickly, right? So a question like this immediately increases the percentage on the test in a class. Okay? If the most missed question on a test was a proof, we probably just throw it out and say, hey, just don't do that question. But here, we've done it. Everybody can do this, right? So the principle, as you're listening to this, and know that if you are listening to this, you can't just watch the video with the sound off, because there's a lot that I'm telling you that I'm not writing on, okay? So don't just watch it. Listen to it, okay? And what you need to hear is that the intercepted arc, the inscribed angle is half of the intercepted arc. And we're going to continue to work with more complicated questions that deal with that principle. Okay? All right. Next question up is 4. And hopefully I had the right, did I have the right answer on 5? Great. All right, so something like this. Yep, okay. All right, it doesn't look great, but all right. We got 10, 4x minus 4y. This is another one of those will go from being one of the most missed to one of the most correct. 3x plus 4y. All right, is everybody in here taking notes? Good. All right, so this principle is built around the idea that if I have two tangent lines off of a circle that come back to the same vertex, that those segments are congruent to each other. Meaning that this is equal to this is equal to this, which we can see that principle being played. All right, let's show it like this so that we see that, okay? Does that make sense? All right, now, didn't know that. All right, which is telling me something that if we didn't know that, either one, we forgot it when we did know it, and we forgot that we knew it at one point, or we're really not watching those lesson videos very closely, okay? So make sure that you're not just half-butting it for the sake of the video, all right? All right, so I can write equations to solve for x and y. What equations can I write? Ten equals 3x plus 4y. Let's write that a little bit differently. Let's write 3x plus 4y equals 10. Is there another equation I can write? 4x minus 4y doesn't equal y, equals 4. What can I do with that? Does anybody know a shortcut to solve that? You could solve by, oh, hold on. Or matrix. What? 2 by 3. Done, son. Okay. So that to me would be maybe a quick and easy way to do it. You could graph it, right? You could put it into slope-intercept form. You could put each of those equations in slope-intercept form and graph it. I'm trying to think. You could, oh yeah, okay. So notice how we have opposites, right? I have a 4y and a negative 4y. So one way to do this is I can add those two equations, right? What's 3x plus 4x? 7x. What happens to your y's? Cancel out. All right, what's 10 plus 4? Equals 14. Divide by 7. X equals 2. Plug it in. All right, so we've got, what, 3 times 2 plus 4y equals 10. All right, 6, so subtract 6. 4y equals 4, y equals 1. Are there any other variables to work with? No, we are all done. We did it! Yay! Hooray us! We is smart. It's not English class. We are learning. That's good. We're learning. And now future classes will listen to this video. All right. And know that at one point we said, that is good. You're learning a lot. All right. We say it a lot. All right. This one I can understand a little bit more. Okay. But our first two most missed questions are ones that there were principles that we had just either forgotten or hadn't learned that really quickly make those a lot easier, right? Okay. Awesome. Number 9. We have square root of 5y, was it say minus 9? Yeah. Minus 9 plus square root of 5 equal, 5y. Okay. All under the radical equals 9. Okay. First step. Minus square root of 5y. Minus square root of 5y. Now I'm going to tell you that there is a step in here that you are likely to forget, okay? That is the advantage to experience, is knowing what things students, likely you, will forget to do. Okay? We can do this. We can get to this step. And in fact, probably most of you will know that we need to do what to both sides? Square both sides. Okay? Square both sides. But I know, because we talked about this, right? I know what you're going to forget to do. You're going to do this, right? And this is correct. But what you guys probably did here is you wrote 81 minus 5y. What do I actually need to consider this to be? FOIL 9 minus radical 5y times 9 minus radical 5y, which does make the equation longer, okay? But it's the only way for us to get it correct. All right. Because this is not 9 times 9 and negative radical 5y times negative radical 5y only. Okay? It's also 9 times negative radical 5y. Okay? So we have foiling. We have 9 times 9 is 81. But we also have 9 times negative 5, or negative radical 5y. So that's 9 minus 9 radical 5y, correct? And then minus 9 radical 5y. Do we understand the middle two terms? Okay? And then we also have negative times negative radical 5y, which is positive 5y, right? Because anytime I take a radical times that exact same radical, I get that value outside of the radical, because really what it would be positive radical 25y squared, in which case it reduces to positive 5y. Does that make sense? We're hearing this? Okay, I hope so. All right, so now we can go in and we need to combine some like terms and reduce some things. 81 doesn't have a like term with anything, okay? Negative 9 radical 5y minus 9 radical 5y is negative 18 radical 5y plus 5y. All right, keep in mind we want to solve for y. Now, let me scroll down here. And this probably turns out to be a lot more work than what you initially did, correct? Okay, so this is one of those highly missed and highly rightfully missed. You okay? Just like, got the shivers, right? Yeah. Okay, so what I would identify is now we want to isolate y. And just like that video of my son, he was having a freaking out. I was just freaking out a little bit. This you won't understand because you can't see what's going on in this video, but Hallie was freaking out. All right, so now looking to move things across to get my y's together, right? So we would subtract 5y minus 5y. So our 5y's are going to cancel, but we're also going to add 18 radical 5y to this side. Okay, so although these cancel, we have 18 radical 5y, sorry, well, yeah, positive. We also want to add 9 to 81, right? So what does that equal? 90. 90. Okay, so when we get to this step, divide by 18, yes, divide by 18 on both sides. And this is where the video is handy because you might not understand all that. So we got radical 5y equals what? 5. Okay, let's make a little bit. Square both of them. Sure. Okay, now one thing that we need to understand is that if I'm squaring the right-hand side because I had to square the left-hand side, do I get two possible answers on the right? Okay. 5y equals what? 25. Divide by 5. Y equals 5. What's the answer key say?
5.
Just 5? Okay, good. That is good. Now you have learned. All right, so that's a much more complicated question, and I think that you guys can do it. The important thing, don't forget to FOIL it. Okay? Does that make sense? All right. Hopefully emphasizing it will help. All right, what was that, 9? 13. 13. Okay, we got, okay. X to the negative first plus y to the negative third. X squared. Y to the negative fourth. Okay. First big rule. Split it. Split it. Split it into two, the sum of two fractions with a common denominator. Okay? X to the negative first over x squared y to the negative fourth plus y to the negative third over x squared y to the negative fourth. That's the step that people forget. It's the very first step. Okay? Now that I have it like this, can I move things above and below the division bar? Now I can. I could not before. All right. So with this, right, I'm going to move this x value down. I'm going to move this y value up. That gets everything to be a positive exponent. Okay? So it gives me y to the fourth over x cubed. Does that make sense? All right, here, I'm just going to move that y up. Right? That's going to give me, what, y to the first over x squared. All right? Here's the problem, though, is that I can't add these to fractions. Why not? I need a common denominator, which is what? X cubed. What do I have to do to this side to get it to be x cubed? Multiply it by x to the first, because then I get to add 1 to that too. Okay? So now I can write y to the fourth plus xy over x cubed. Is that our answer? Awesome. I love it when I know how to do things. Do we understand? I kind of skipped a step at the end. Do we get it? Okay. So yeah, we went ahead and just threw all of that because we knew we were going to get a common denominator x cubed. Let me just go ahead and show it. All right, so we got y to the fourth plus y to the fourth over x cubed plus xy over x cubed, right? And so then we just bring it like that. You got me? Okay, good. Are you smelling what I'm stepping in? Nice. That's good. All right, where did we leave off? What number was that? That was 14. That was 13. 13, we need 14. 14. Okay. And this one, we've kind of consistently struggled with these. A to the fourth. But hopefully that's good if we learn. A cubed, b to the negative 2 squared all over cube root a cubed e to the negative 6th, not under the root is square root of b to the negative first. Okay. Numerator first. Simplify numerator first. Okay. I want to get a to the fourth and b squared out of the radicand. All right. Remember that there's a 2 there. All right. So 4 divided by 2 is 2. All right. 2 divided by 2 is 1. I love it. It's like being in 3rd grade again. All right. What do I do with my exponents here? Multiply, because I'm taking exponents to an exponent, so we use the power rule of exponents. What's 3 times 2? 6. And what's B, what's negative 2 times 2, gang? Close. Negative 4. Very good. All right. Now, let's go ahead and simplify this. All right. We want A's with A's, B's with B's. 6 plus 2 is 8. Very good. That's good. You're learning. All right. 1 and negative 4. 1 and negative 4. Negative 3. All right. Are we done with our numerator for now? Yes. Very good. Yeah. All right. All right. Let's come over here. We'll work out the denominator just kind of next to it. All right. Now we're taking a cubed, right? So we're taking 3 divided by 3 and getting 1. And we're taking negative 6 divided by 3 and getting negative 2. Very good. Now, this is the part, this part right here, this square root of b to the negative first. This is the part where I think will probably cause the problem for you if it didn't on here. All right, what is the exponent to b in there already? 1, right? If I have to, here, let me go ahead and put it in like this. What is the root? 2. So if I wanted to pull that out, right, and leave it in a set of parentheses, what is that? No. B to the 1/2 to the negative first, right? So that's going to become a to the first, b to the negative second, and now I'm going to apply that, and I'm going to get b to the negative 1/2, okay? Now we have a to the first, and we want negative 2 minus 1/2, which would be what? Negative 2.5. What is that? Negative 5 halves? Negative 5 halves, if that helps. Okay? So this is my denominator. All right, we're not done yet. Let's go ahead and set these things up. So I've got a to the 8th, b to the negative 3rd, all over a to the 1st, b to the negative 5 halves. All right, and let's decide where we're going to move things. Do I want to move a up or a down? Move a up. Okay. And do I want to move b down or move a b up? B down. B down. Because negative 3 is bigger than negative 2.5. And so if we're going to make it positive, right, we're going to move this down. All right, so just so that we're seeing what is happening, right, as we do that, we got a to the 8th, a to the negative 1st, okay? Down here we've got b to the 3rd, and b to the, if it helps, negative 2.5, okay, to see it that way. Carry this down again. So finally, we have a to the 7th and b to the positive 1/2. Okay? There are lots of places to make mistakes on a question like this. Okay? Okay? But is it doable? None of those steps are terribly, terribly difficult, but it's when you have to do all of them, it's easy to get lost, right? It's easy to forget something. All right. A lot of knowing what to do just kind of comes with experience. But I will say this, somebody that I was really, really proud of on our last test, just because of what they told me afterwards. A certain student came to me after scoring a perfect score on the last test, and they were super surprised. They didn't believe it, and they showed me like 10 sheets of paper. And they said, I did each of the questions on review like 10 times until I basically just memorized how to do it. And that was David. And so David rocked it out, right? So my point is this, is that you need to do what you need to do in order to be successful. And that's true in life, it's true in everything. David found out what he needed to do in order to be successful, and he was. But it was a lot of work, right? You put a lot of time in. Some people may not have to put in as much time to get the same result, but you can't judge your necessity for success based upon somebody else's necessity for success. If somebody can study for 20 minutes and get a 14 on a test, that doesn't mean that you can do that, right? Figure out what it is that you need to do. And if it's a ton of extra work, then it's a ton of extra work. But it really comes down to like how much success do you want to have? And then figure out what it's going to take to get there. Okay? Mariana was another one. Fantastic. Aced it. Okay? Super impressed. Okay? Not an easy test. Mariana, I'm guessing that you put in a lot of work. Yeah. Like her notebook is almost empty and we're only like 4 or 5 weeks in from stuff that she's written down and how hard she's worked. So, you know, Mariana and David, super impressed. All right, that was extremely slow clap. You'll get the next clap in like 20 minutes, right? And the next one after that will be 10 minutes and 5. That's how I feel like our assemblies should have gone. It's like you get one clap at the beginning, and then by the end, those increments, you know, it's what is it, exponential decay, so that by the end, you finish the clap at the end of the assembly. That's my personal thoughts and feelings. We can close on that. All right, we're not done. All right, number 3. All right. Right? That's where we're at? Okay. Now I'm going to read this rather than write up the whole thing. It says there are 128 blue cars and red cars in a parking lot. All right? So I can write an equation based upon this. Okay? Red plus blue equals 128 cars. Okay? Red plus blue equals 128 cars. Okay? Now, is that going to make it worse? If I could have done it all in purple, I would have. All right, and there's probably a way for me to. I just don't want to figure it out. All right, if the number of blue cars exceeds, so we have blue exceeds something by a certain amount. How much does it exceed by? No. Well, okay, well, if it doesn't exceed by 4 times, it exceeds the number, exceeds 3 times the number of reds by an amount. By what? By 4, which means it's an imbalanced equation. Blue is 4 too much. So what do I need to do? Subtract 4 so that I can get a balanced equation. Now, what is on the other side? 3R. It exceeds 3 times the number of red cars. So 3R. Okay? How many of each car are in the parking lot? All right. There's 2 things that we could do. Okay? I'll give you, I don't know, do you want 1 option or 2 options? You can do a matrix. So just so that you see the matrix option, okay, that would be red plus blue equals 128, and then change this equation so that you have blue minus 3R equals 4. Okay, move this over here, move that over there. Now I have a system of linear equations. It would help, but if we, so that we don't mess it up, what we would have negative 3R plus B equals 4. There. Because, that would be a mistake that you could make, is that if you had it in that order, it would mess up your matrix. Okay? Or, okay, so this is option 1. Option 2 is that we take, we find red equals 128 minus B. We come down here and we say B minus 4 equals 3 times 128 minus B. B minus 4 equals whatever 3 times 128 is. Is that what you think? Okay, 384. I would add 4 to that. I would add 3b to both sides. Right, we get 4b equals 388. Divide by 4. B equals what? What's 388 divided by 4? 57. 97. Okay, so blue equals 97. Okay, come back up here, substitute red plus 97 equals 128. Subtract 97. Red equals what? 31. Okay, and then you can double check. Okay, so there is a change equation and substitute, or change equation and solve via matrix. Okay. I will give you 5 seconds to write it down. That's how generous I am. I'm going to give you 5 times more than what you asked for. You did, okay. Oh, yeah? Yeah, you did B equals 3R plus 4. You changed the second equation. Yeah, you can do that. But you have to make sure that if you do that, that you're substituting back into the first equation and not back into the second equation. Okay. Hold on, hold on. This is caffeine. But that's going to run you, how much are they a piece? They're like $4 a piece, aren't they? Are they even good? Like, do they like? This one's Tropical Burst. You got $4? I'll give you $1 back. Oh my God, you're going to be bouncing off the She's literally going to be doing your son. She's going to be like. There you go. All right, that was number 3. Number 10. Here, do you want? You're making it way too difficult. No. No, you're gonna freaking break it open. All you do is you just have to break the bottom and then the. I'm sorry, I don't have nails. That's, all right. All right, number 10. 10's a good one to go over. 10. Did you drink it? No. Oh, I just chug it. There's not enough there. Basically, if you chug it, you probably won't even taste it. No, it'll probably make you need to. It'll make you need to pee. It's basically it's vitamin B12, B6, and caffeine. All right. All right. Let's pay attention. All right. So the first thing that I want to do here is I want to make any negatives inside a radical what? I. So as I rewrite this, I'm going to go ahead and put, because all this is multiplication up here, I'm going to rewrite it like that. Do we understand that? Okay. Plus, I got I, radical 9, radical 3, minus 3i. And I'm going to pull out the i's from these, which sounds grotesque. Okay. All right, radical 3 times radical 3 is what? Radical 9. Okay, that's fine. Okay, which is, what's radical 9? 3. So we get 3i there. Okay, plus, okay, radical 9, what's the square root of 9? 3. So I got I times 3 times 3 times radical 3, right? Okay, what's 3 times 3? 9. So I have 9i radical 3. They're all attached, so I don't get to get rid of the radical 3. Okay? Minus. Did somebody say they're so confused? All right, where do I need to go back, Omar? First step? Second step. Did we get this part, this first section? First step? Third, this step. All right, do we get the 3i? Okay, so we understood how we made this, that all came down. Does that make sense? All right, so I comes here, this. You got it? Okay. All right, hold on. So we got 3 here. What do 2 i's become? -1. Okay. Okay. Okay, leaves an I. Radical 3 times radical 3 is 3, or radical, okay, if we want to do that. You want to make that radical 9, can. Okay. 3i. We can't reduce anything there. We can't reduce anything there. All right, let's try to reduce this line up here. Okay, we got -3 times -1, which let's leave that for now. We got I. Can we reduce radical 9? 3. Okay, 3i. A lot of this you can do in fewer steps. All right, what's -3? Let's finish it. -3 times 3 is +3, right? Times 3 times 3 times I. 3i plus 9i radical 3 plus 9i. Combine like terms. All right, 3i and 9i is 12i plus 9i radical 3. And I guarantee in this one they're probably factoring out the I. So you're getting 12 plus 9 radical 3 I on the outside. Is that right? Is that what they did? All right. Very good. We're going to stop right there.